Good morning, ladies and gentlemen of calculus. We're going to move on to note card 23 today, which has to do with acceleration. And I hope you remember that yesterday, do you remember that I mentioned acceleration yesterday?
Yes.
You did, okay. And the context is that, remember we had x of t would be our position, and x prime of t is going to be our velocity. Very good, thank you, Kylie. And then if you take x double prime of t, it's going to be the same as v prime of t, which is going to be equal to a of t, which is acceleration. So what you're looking for is this hierarchical relationship, and here's another form we have, this d squared s over dt squared. That's a notation for second derivative. Okay, so you'll see this sometimes. So I like this example because it gives different types of notations that we have to be ready for and recognize what that happens. And we have a positive acceleration is pushing a person or object, while negative acceleration is pulling a person or object. And one thing, when you're driving a car, you can really feel that. When you're accelerating, right, you're pushing, what happens? You feel your head go back against the headrest, right? And when you're braking, you go the other way. So driving a car is a very good way. Okay, now here's another thing that's important here. A particle's speed is increasing when the signs of acceleration and velocity are either both positive or both negative. And we're going to find examples of that. And a particle's speed is decreasing when the signs of acceleration and velocity are opposite. One is positive and the other negative. So you can be, your speed can be still increasing, but your speed can be going. Anyway, we're going to get into examples of that. Okay, so let's go to our next example here, which is right here. Okay, so here we have an example just like the one we started yesterday, except it goes to another level here. And we have to remember that, as Aaron mentioned a little bit earlier, number lines are our friends. Very good. And so let's go over this right here. An object for t is greater than or equal to 0 is moving along the y-axis. Usually I told you that we're talking about x-axis. Well, here's an example of a y-axis, but it ends up being essentially the same thing. So we have our position, this case s of t, measured in meters, is given by this equation here, where t is measured in seconds. During what intervals of time is the object moving to the right? So what are we going to have to do with this for part A? If you remember back all the way to yesterday and look at your notes from yesterday.
Wait, where? Oh, right here. I don't know why I'm going to flip my page.
What are you going to be looking for? What's our process of
We got to find the
critical numbers? Everybody see that? Okay. To me, that would be sort of the first thing you think about, because what happens at those critical numbers?
That's when
the speed changes.
When
Not the speed, but the direction changes.
Okay, Aaron said this is where the direction changes. Okay, I'm going to make a slight correction to what Aaron just said. He said where things changes. Well, not necessarily changes, but is zero.
It's zero, yeah.
Because it's possible that you could slow to zero and not go back the other direction, right? If I'm walking like this, okay, I'm slowing down, I'm slowing down, I'm slowing down.
And he stops.
and I stop, I can either keep going ahead like this, or I can go back. Now, normally, I'd expect to see going back the other direction, but not always the case. And then what that comes down to is something we talked about in pre-calculus, this long word that starts with an M. You remember that long word starts with an M? I'll tell you what it is, multiplicity.
Multiplicity, got it.
Okay? So that has to do with multiplicity. You didn't have any context to figure out what. Okay, so how do we find our critical numbers here?
We have to set the prime equal to 0.
Set the prime equal to 0. So let's go find the prime. So we're going to say v of t is equal to s prime of t, which is what?
What? Oh, 3t squared minus 18t plus 25.
3t squared minus 18t
Plus 24.
plus 24.
And then you can take out that 3.
So we set this equal to 0 here, and Kylie suggests factoring out a 3. So we do that, we get t squared minus, what is that, 6t? And plus 8. And now, if you divide by 3, you have 0 is equal to, and you can just factor what's left, right?
Yeah.
And what do we have left here?
I think it's 4 and 2.
4 and 2. And a lot of these times, you're going to be minus, minus. So 4 and 2, and you check. And then, okay, so there we did that first thing. Found the critical numbers, set the first derivative equal to 0.
Then I make a number line.
And then we do what we require friends. So we do a number line here.
You invite your friends over real quick.
Invite our friends over. Yeah, our friends over. So what do we do with our friend here?
You put like BT right at top and then
Yes, so V of t is going to go on top. And here they're using S of t, so I'm going to say S of t goes on bottom. Okay, and what else?
you need like do your critical numbers on it.
Okay, we're going to put 2 and 4 here.
And you
And
plug
so-
in, let's say between like 2 and 0.
Yeah, so now we can go, yeah, if we plug in 0, we get negative times a negative, right?
So you get, yeah.
So we know we have that, and then between 2 and 4, and then at greater than 4, we have positive times positive. So we can justify because where is during what intervals of time is the object moving to the right?
When it's below 2 and above 4.
Yeah, below 2 and above 4, Aaron says. So let's go ahead and articulate that. Okay, we say object, and here's another thing, moving along the y-axis and moving to the right, those are not, because y-axis I generally think of as being a vertical axis, so I don't know, these don't exactly 100% correspond because I normally think along the x-axis for that. But anyway, we do the best we can. So particle moves right on what interval?
Would it be negative or 0? Oh, 0 because time is,
Yeah, 0, yeah, because here they give us the limitation right here.
since it's greater than or equal to, do you do the square?
Well, let's just go ahead and, I want to talk about that in a minute. I want to finish writing that out here, and then I'm going to mention what Aaron suggested here. And also what other interval? 4 for infinity, okay? Now, as a matter of technicality, when you say, okay, the object is not moving to the right now, for greater than or equal to 0, you could bracket this on the left possibly, But if the thing is actually motionless at 2, the thing is not moving to the right until greater than 4, okay? Or less than 2. But for the purposes of this class, you're going to want to use parentheses most of the time. Okay, so let's look at that. And then the justification, because B/C what? What is your justification?
If math says so.
My
That's-
number line, my good old pal tells me,
Your pal tells you?
yeah.
Well, here's what thing is your number line itself is really a graphic organizer to help you visualize what it is, but it's not the official justification. What's the official justification of this?
Because it's above 0.
Okay, yes, okay, and what it is, you got to be careful about the word it, because it's above 0. Let's try to stay a word from the word
How about
it.
B of T?
Because V of T, and what happens is you've described what V of T is here because you've written this up here, is greater than 0 on those intervals. So that's going to be your justification. And the thing you can do when you do these problems, and you see during what intervals of time, you can actually write the answer, you can write the justification before you find out what the numbers are. Because you know, and so sometimes it's better to do it that way because it can help keep your head straight to figure out, okay, where do I need to go with this? Thank you.
I have a question.
Yes, sir.
Do we ever get like to any problems where we're using the z-axis in here?
The z-axis, the third dimension here, I can't think of any right now. Now, what happens when we get to integrals, we get to volume of rotation, which isn't in itself a z-axis consideration, but it does bring in the third dimension.
Remember, it was last year, whenever I went to that Nathan Nail Academy, I got to like sit in on some of their classes, and the calculus class was one of them.
Uh-huh.
Yeah, they were working on stuff with the z-axis.
Oh, they were?
It's like,
Okay, yeah. Well, what happens is, that's going to be not your first semester calculus class there.
it was second semester.
It was second semester, yeah. So that's what. But what happens when you do in this class, this will get you ready for that, essentially. Yeah. Okay. Next, find the velocity of the object when the acceleration is 0. So what do we have to do to find the acceleration?
You gotta slap on that A of T.
So A of t is equal to v prime of t, which is, what is going to be v prime of t? Again, we're taking this equation here.
So find that, the prime that,
Yeah, what is our derivative of this?
16 minus 18.
So we have 6t minus 18. Okay, and it says find the velocity when the acceleration is 0. Let's find the acceleration of 0. How do we find the acceleration equal to 0?
Is that equal to 0?
0 equals 6t minus 18.
Which is just going to be 3.
So we add 18, divide by 6, so t is equal to 3, right? So that's t is equal to 3 seconds. And so what do we do with this 3 now? Because that's going to be when the acceleration is 0.
Find the goal.
We take this 3 and do what with it? Plug it in where?
The velocity.
Plug it into this thing right here. Equals s prime of 3, which equals 3 times 3 squared minus 18 times 3 plus 24. So that's going to be like 27 minus, what is that going to be? 54? 27 minus 54 plus
24? Oh.
24,
-3.
-3.
Yeah.
Okay, -3 here. So -3,
The velocity?
yeah, so it's going to be -3 what?
Meters per second.
Yeah.
Meters per second. Okay,
Yeah.
so we found it. Okay, okay. Next, in part C, we're sort of bringing the acceleration and velocity together.
Oh,
All right.
the speed.
And I want to show you something, because I'm going to show you another number line here that we're going to kind of put this together.
Another friend.
Another friend. We got another friend. I'm going to drop this second friend right below our first friend.
Oh, see what if I don't have? Yeah.
You just drop it.
Or you can put it down. You can put it down below. You can put it down lower.
My
Okay.
justification under my first friend.
No, that's fine. But what you have here is that's going to be 3. You put 3 here, and here you put
It's unfortunate.
A of t here, and below you put s of t.
I'm just gonna move
Okay, and so now we evaluate on the top whether our acceleration we know the acceleration is 0 at 3, right? But we're going to find out which way it goes. So how do we figure out which is which here?
Start plugging in numbers.
Plugging in numbers, right? So what number you want to plug in?
0.
0.
Just because that seems easy. It's -18.
So -18. So we know to this side of it is negative. And what about greater than 3?
And
Positive. Okay, what happens to the function is the function is actually concave down when when acceleration is negative, and concave up. Concave up. So that brings in concavity. So that's like that's a pre-introduction to what we're going to be doing next. So then we take is the speed of the object increasing or decreasing at t equals 2.3 seconds.
Decreasing.
So let's go look at our number line up here, right? Where do we see 2.3? Right here. So what is our velocity, positive or negative?
Negative.
Negative.
Is our acceleration positive or negative?
Negative.
So what is the speed going to be, increasing or decreasing?
Decreasing.
No, it's increasing.
Increasing. Here, let's look back
A
here.
particle's speed is increasing when the signs of acceleration and velocity are either both positive or both negative.
Okay, so positive. Positive.
Okay.
And the justification is because S of t and not S of t, not S of t, V of t and A of t are both negative, right?
Why? I'm just saying.
And A of t are both less than 0, are both negative. Find the average acceleration of the object for the time period between 1 and 3, indicate units of measure. Average acceleration. Okay, between 1 and 3, well, at 3, we know that that's 0, right? So if we plug in 1,
-12.
we'll get -12. So we're going to get -12 over 2, which is going to be -6 meters per second squared, I guess. That'll be an average for that. So anyway,
Oh, because 1, okay,
yeah, so it's like B minus A, right?
yeah.
So it's like F of B minus F of A over B minus A. So you get 0 minus -12, so minus,
I got it now.
anyway, minus 12. So anyway, we're going to be going on some tomorrow where we are going to be given some
problem?
Yeah, some problems. We're gonna work on this, on some notes and so forth tomorrow, okay, on this? Or actually Monday. Thank you.
Oh, is today Friday?